Welcome to Chapter 1, Lesson 5, Problem-Solving Strategies. Our first problem-solving strategy that we're going to go over is the look for a pattern strategy. And what you do when you're looking for a pattern is you analyze the first few numbers in that pattern and identify a rule that is used to go from one number to the next. Then you want to use that rule to extend the pattern and find a solution. So our problem here says Ramon got a text from Angela. After 10 seconds, he forwarded it on to 2 of his friends. After 10 more seconds, those 2 friends forwarded it on to 2 more friends. So if the text is forwarded like this every 10 seconds, we want to know how many people total received Angela's text after 40 seconds. So the original time, we started off with 0 seconds. So that one person had it. After 10 seconds, remember, he forwarded it on to 2 friends. So 2 people received the text after 10 seconds. After 10 more seconds, so we're at 20, those 2 friends forwarded it on to 2 more friends. So that's at 4. We want to figure out how many people received that after 40 seconds. So we want to look at a pattern here in our first numbers. How can we get from 1 to 2? I could add 1, but is 2 plus 1 4? No, so that's not our rule. How about times 2? 1 times 2 is 2. 2 times 2 is 4. So then 4 times 2 is 8. And 8 times 2 is 16. So after 40 seconds, that message is getting forwarded on to 16 people. We want to know how many people total have received that text from Angela after 40 seconds. So that means it's our original person with the text, plus the next 2 people who got it, plus the next 4 people who got it, plus the next 8, plus the next 16. So we're going to add all those together. So 1 plus 2 plus 4 plus 8 plus 16, which gets us to 31 people total receiving that text message after 40 seconds. So I want you to try the look for a pattern strategy. So pause here and see if you get the same answer that I get for what color the 50th bead is going to be. If you get it wrong, come check with me and I will do my best to help you out. So it says here, Tyler makes a necklace by stringing beads with the following colors: red, yellow, blue, red, yellow, blue. If he continues this way, what will be the color of the 50th bead? So what you need to do here is you need to recognize your pattern. R, Y, B, R, Y, B. Right, and we're at 1, 2, 3, 4, 5, 6. So every third bead is blue. So what I'm going to do is I'm going to count by 3s up until I can get close to 50. So I've got 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48. So our 48th bead will be blue. 49 then will be red. And 50, you got it, will be yellow. So that was me analyzing the pattern and following it out until I could get to the higher numbers. Our next method that you can try is the guess, check, and revise. And that says to make a responsible guess and then check it in the problem. You can use the results to improve your guess until you find the solution. So our problem here says each hand in the human body has 27 bones. There are 6 more bones in the fingers than in the wrist, and 3 fewer bones in the palm than in the wrist. So we want to know how many bones are in each part of the hand. So what we're going to do here is we're just going to guess, check, and revise. So we want to know our palm, our fingers, and then the wrist itself. So we know our palm, there are 3 fewer bones in the palm than in the wrist. So it's W minus 3 for the palm. For our fingers, it says there are 6 more bones in the fingers than in the wrist. So it'll be wrist plus 6 here. And then over here will be our total. We want our total to be 27. So what we're going to do is we're just going to go, I'm going to pick a number. Let's pick 5. So then the number in my palm is the number in the wrist minus 3. So 5 minus 3, which would be 2. In my fingers is the wrist plus 6, so 5 plus 6, which is 11. My total is adding all 3 of those together. So 5 plus 2 is 7, plus 11 is 18. Is 18 27? No, it's too low. So I'm going to have to pick a higher number. I'm going to pick 10. Okay, I'm just kind of going by 5s. 10 minus 3, 8. 10 plus 6, 16. 10 plus 8 plus 16 is 34. Does that work for us? 34 to 27? 34 is too high. So 10 is too high. So I'm going to go in and retry again. Our number has to be somewhere between 5 and 10. So I'm going to go right in between and pick 8. So then our palm would have 8 minus 3, which is 5. And our wrist would have 8 plus 6, which is 14. 8 plus 5 plus 14 is 27. So boom, that's the same. There's our answer. There's 8 bones in the wrist, 5 bones in the palm, and 14 bones in the fingers. So here I want you to try the guess, check, and revise strategy. Check with me, and if you get stuck, ask me in person, I guess. Colin sold student tickets and guest tickets to a school play. He sold a total of 154 tickets in all. He sold 8 more student tickets than guest tickets. How many of each type of ticket did he sell? So we've got student tickets, guest tickets, and then total tickets. And this one would be guest plus 8 because he sold 8 more student tickets than guest tickets. So 154. They're both pretty equally split. So I'm going to go, half of 140 is 70. So I'm going to pick 80 for my guest ticket. And I'm going to go, our guest plus 8 would be 88. 80 plus 88 is 168. 168 and 154 doesn't work. I got to get smaller. So now I'm going to go, let's try 70. 70 plus 8 is 78. Now we're at 148. Okay, little closer to 154, so I'm just going to get a little bit bigger. My favorite number is 3, so I'm going to go up by 3. So we're going to go 73. 73 plus 8 will get us 81 student tickets. 80 plus 70 is 150. 3 plus 1 is 4. Perfect, 154. So there's 81 student tickets and 73 guest tickets that were sold. Our third strategy here is the make a table strategy, which we've kind of already been doing. So a table allows you to organize your information in an understandable way. So a vending machine accepts dollars, and each item in the machine costs 65 cents. If the machine gives back only nickels, dimes, and quarters, what combination of those coins are possible to make change for $1? So what we're going to do is we have to figure out, number one, how much change we're getting back. So if things cost 65 cents, we can put in $1. So $1 minus 65 cents gets us 35 cents. So we need to figure out the possible ways that you could get 35 cents using nickels, dimes, and quarters. So we have nickels, dimes, quarters. So I'm going to start off right away using my big bucks here, my quarter. So if I have 1 quarter, that's 25 cents. To get to 35 cents, I'll need 1 dime. There's one combination. And now, boom. I could still get to 10 cents another way using nickels. So there's another combination. Now I'm out of my quarter strategies, so I'm not going to need quarters anymore. So I could just basically put zeros down the line. Now let's do dimes. What's the largest amount of dimes I could have? 3, because that gets us to 30 cents. And then we would need 1 nickel. Take 1 dime away to 2. 1 dime equals 2 nickels, so we're at 2 and 3. Take another dime away, we're at 1. Add 2 more nickels there to 5. And then finally, we could have only nickels coming back. So 5 times what equals 35? 7. So the amount of combinations that we could have would be 1, 2, 3, 4, 5, 6. 6 combinations are possible. Now you try this make a table strategy. It's telling us that the product of 2 whole numbers is 36. What are the possible values for the sum of the 2 numbers? So I'm just going to go here and think of, so we've got our 1 number, our 2 number, and the sum. So 1 times 36 would work. I'm just going to throw the numbers out first and then we'll add. 2, does that go into 36? Yes, it does. Because 36 is an even number to get us 18. So 2 and 18. Does 3 go into 36? Yes, it does. 12. How about 4? Does 4 go into 36? 9 times. So 4 and 9. And you can see our numbers are getting closer and closer together. So once they start to overlap, then we've run out. Can 5 go into 36? Is 36 divisible by 5? No. 6 go into 36? Oh, 6 times 6. So since our numbers are the same there, we know that we found every number possible for 2 whole numbers. We started off at the smallest whole number that's possible and went up until we reached each other. So our possible sums would be 37, 20, 15, 13, and 12. And our final strategy that we have is the work backwards strategy. So if a problem starts with a result and asks for something that happened to earlier, that's when you're going to use this strategy. So it says Kendra spent half of the money she had this morning on lunch. After lunch, she owed her friend $1. Now she has $1.50. How much money did Kendra start with this morning? So we need to work backwards. Right now, we've got $1.50. That's after we loaned our friend $1. So we have to undo that. Loaning our friend $1, we're going to add $1 to get us to $2. Then we had spent half of the money we had on lunch. So 2 is half of what? 4. Right? Because we take half of it, add the other half to get to 4 total. So this morning, Kendra started off with $4. So you start with where you're at, and you undo everything that happened earlier. And you're going to try the work backwards strategy. So read through, start where you're at, and undo as you go. So some passengers boarded a bus on the bus station at the first stop. 9 more passengers boarded the bus. At the second stop, half the passengers exited the bus, and then that left us with 12 passengers on the bus. So we want to know how many passengers boarded the bus at the bus station. So right now, we're at 12. That's after half of them got off, so we need to add 12 to that. So there's 24. At the first stop, 9 more passengers boarded the bus. So we need to take those 9 passengers away to get us to 15 passengers originally. Because you're doing the opposite. So if 9 get on, you need to take 9 away. If half get off, you need to add half on. Working backwards, you're doing the opposite. So 15 passengers originally boarded the bus at the first station, or at the original station.